to me, if something's software defined, you take a bunch of commodity components of the business, a CPU, a network chip, power supplies, memory, disks, and you assemble them, and then you put software on it. And then that means that whatever you're doing with that, if the software is managing it, then it's software defined. So the way our system works is it's a pure software package. You put it on a piece of hardware that has a disk, CPU, memory, and a network port, and we will manage that as a piece of hardware that stores data, and we do it in such a way that to us it's virtual. You can use any kind of hardware you want, you can rotate out new hardware and put it in. So what we care about is the data that's residing there, but because it's so easy to move things in and out of our environment, we have no concept of migration because we're not bound to the hardware layer, we're bound to the way the software system manages your data. And so as a result, if you talk about truly being software defined, this is software defining your storage infrastructure and truly making you independent from your hardware. You could spend a lot of times managing bits and bytes on an individual volume through some complicated firmware on a RAID card or otherwise, which adds increased probability of failure, increased loss of data. From our point of view is there's a volume, it can be whatever, from a SAN, it can be just a regular disk, and that we manage a pool of capacity for you. If you want more capacity, just put more of that stuff in. If you want less, then retire some of it out. And rather than actually try and dwiddle with every bit on a little disk or try and find out how to do it across a couple disks better, just either you have storage capacity you plug in or you don't, and let the software manage the capacity for you and tell you when you need more or help you get rid of some. But let's try and use some concrete examples here. We talked about how we've got a mechanism to get them from file in, and a lot of applications will be working in that way. But let's take, for example, body-worn cameras for police departments. It's a relatively new area, but it's a really important area. There are large objects, there's going to be a lot of data. A bunch of the systems do have legacy file interfaces, but the world is starting to look at more open interfaces to object storage as a place to put these data. Okay, so you might attack that application in particular as a place to start using object storage because it's got the biggest data requirements. And oh, by the way, one of the advantages of object storage is that you actually own your data, unlike the current application framework model. So current application frameworks say, put all your data into my application. I'll have some kind of database in there, but I won't tell you how it's formatted. And I actually won't tell you the format of your data when you put it in my application. And then I'll let you operate on that data through the UI provide for you. The opportunity of object storage is to allow you to free your data from that specific application. So in the case of the police video, what you really focus on first is how do I get the data into an object store, which I can do through these file system interfaces or through native integrations, which are definitely being used these days. And then now I've got my data, how do I get metadata associated with it? If you do a native interface, you get metadata associated with it. If you come through a file system like ours, we can actually help you put metadata on it as you put into it, and then once you've put it in there, you can actually post-process and add additional metadata. So now your data is actually independent of how you view your data. You own your data, you own the actual metadata, and you have the opportunity to enhance that metadata through standard tools that are available that know how to look at that data set and extract metadata from them. So now you actually own all the pieces that'll allow you to find something for, let's use a video that's in car 49, officer, Pete, right? And you want to go find it. Well, that metadata would be associated with that particular file, and now you can just search on that metadata, and then how you look at it, say you want to look on it in a GPS map, or maybe you want to view the video. Each of those are about how you view it. It's not actually about the application that it's in, because the data is already yours, owned, and in your object store. You have all your metadata, so now you have all the information necessary to display it or visualize it. So now you take that information and you decide how you want to see this data. So now you take an application and try and move one application like that at a time. If you just have existing applications that only need to talk file system, they're a candidate for using the object storage, but you want to pick one that you can actually go off and start talking object, because what it does is it frees your data from the application. So if you have an application that you feel like owns your data, and I'll give you a good example, iPhoto. It owns my data, it owns my metadata, it owns my way of looking at the world, and it really stinks because I don't actually own my data and I can't get any other way of getting to it. But in this model, you own your data and you own your metadata, and now you can decide how you want to view it.